Hi, my name's Lucas.
Brandon.
Hi, I'm Jack.
I'm Alex.
This is our final project for CS595 Capstone. We did a web comment extension for Chrome that we're going to show you.
Here's kind of a recap of our grand vision that we already talked about in previous presentations. So our grand vision for this project was to develop a fully featured web application that allows users to leave comments on any web page via the URL. The front end is implemented as a browser extension that automatically loads comments associated with the URL of the current would be viewable at the domain or the URL level. Users log in to post comments, and then verified users could also opt to post their comments anonymously. Comments could be rated, sorted, and reported, and users would have manageable, reasonable tools to manage their account and their comments.
Our semester goals haven't really changed. We just wanted to make the extension available for beta users. It's not great to install with the Chrome developer mode, but we're still testing features. We just want to get our base features down so you can submit and view comments on the pages. Authentication should work well, and the design is scalable if this were to be developed further in the future. I'll be taking us through the general architecture of our application with a high-level system diagram. This is just kind of how our system works, and this is actually almost identical to what we presented in the last presentation. The only part that's changed is where session management is occurring. So session management moved from Cognito to RDS. So this kind of just lays out how we're using AWS resources to manage where comment data is stored, how it's retrieved with the Lambda, and how requests and logs and users are all kind of set up. I'll talk about the REST endpoints. This is just when you make GET and POST requests, we can understand what kind of messages the client is trying to send. So URLs are going to contain things like query string parameters, headers, or one main header, which is a session ID, and JSON body content. These things tell the Lambda what order to put comments in, what kind of information you're looking to post, like where you're trying to post a comment at, and if you're trying to get user info. Those are all through different endpoints. The server methods are all accessing database resources that we'll kind of talk about later. And once the data comes back from the database calls, we do a little bit of management to return it in a schema that the client will understand. And this will help take, sorting capabilities and sorting functions and stuff like that out of the client to make it really simple. This was a diagram that we presented earlier, I think in the last presentation, but it's changed a little bit. I'll quickly take us through it. This is, for example, one kind of request that the extension could make to our server. So at the top, I'm saying we're posting at a comment endpoint. You're going to include a session ID, a URL, and the comment text that you want posted. We're going to first get the access token from the session table to make sure we have a valid user. If the access token is expired, then we'll try to get the refresh token from the RDS and send that information to the Cognito, and we'll get a response of another access token, which is not expired, hopefully, and we can decode the access token. It's a JWT containing information like username and expiry times and stuff. So we can use that username to post it into the comment table, and we'll get the response of a success, hopefully. So it's kind of like just an example of one of our API calls. There's a lot more calls, and they might actually vary more than this one does. The last thing I'm going to talk about is AWS Cognito. Cognito is really nice because it provides a kind of secure authorization service that's at like a better level than we could have home cooked ourselves. So it's OAuth 2 compliant. So we use Amazon Web Service. They host the login page, and we will use that. We'll send our users there. It'll return secure tokens. We'll use that information to make sure our users are authenticated in the app. And finally, once a user logs out, if they do, then we'll revoke their token and they will no longer be authenticated. Other things that it provides is like email verification, which is really nice because we don't want to have to concern ourselves with how do we set up an email service to make sure, users can verify their account. How do we want to, we don't want to have to worry about making sure users can reset their password. So AWS Cognito really handled this all for us.
All right, here's what the final design, or the current state of the database looks like. As you can see, there's 4 different tables. 3 of them are related to URL and domain data. And then we have also store in the same database session information. So this lives in an instance of MySQL database that's on AWS. And thanks to AWS, if we ever wanted to scale this application, it would be very easy to scale this database. However, I think in the future I would design it a little bit differently. I would move sessions to its own data. All of our user information is stored incognito, and I really don't have a way to protect the integrity of like the username, check it against Cognito and stuff. So in the future, I think I would change that around a little bit.
This is what our user interface looks like. It puts a little icon right next to the address bar in Chrome. When you click on that, you get this pop-up window. A couple things happen when the pop-up opens. It's going to make a callback to our backend to verify that the session is active. We're storing session information just in a cookie on the local machine. And then it's going to query the Chrome or the active Chrome tab for its URL, and then make another call back to our backend to load the comments for that URL. That happens automatically every time the pop-up opens. We have a tabbed interface, so we have other tabs for account management, for UI preferences, and we have the ability to easily add more if we wanted to in the future. So here's kind of an overview of the front-end work that we've completed. We have the tabbed interface with the comment tab and the account tab. Comment tab automatically loads comments. You can post comments if you're logged in. If you're not logged in, there will be a little pop-up overlay that comes up and lets you know. Have some animations on some of the UI elements to preserve screen real estate. They'll expand and contract in response to user focus. We're using a background script to maintain the state of the pop-up window. Had some issues with that early in the semester. It loads in like a completely new context every time you open it. So we need some way to maintain the state information. Done some authentication and session handling, like I said, storing session information in a cookie, and making callbacks to the back end to verify it, and pop-up overlays to communicate problems like I said, if you're not logged in, it'll let you know, hey, you've got to log in or you can't post comments. If for some reason you tried to post a comment and it failed, say there was a server error, it'll pop up and let you know that too. For remaining front-end work to achieve our base functionality, we want to implement some sorting of comments. There's some few minor bug fixes that we need to do for Mac OS. And we'd like to help users to distinguish their own comments. As you can see in that image, there's a whole lot of comments on that page, and they kind of all look the same. So thinking either color code them or add a different tab so that users can view their own comments and only their own. And lastly, we'd like to paginate the comments so that we don't end up with just a super long list trying to load all at once.
So here's a quick demo of our extension. So you can see we're already on the Wikipedia page for ducks. So we can pop open our extension. And here is all of the comments for this page. We can see there's quite a few already. So then we can come down here to the account tab, and we can see we're not signed in. So you can either register a new account, which will force you to enter an email, and then you need to verify your email, or we can just sign into an account that's already existing. So I will do that. You can see here I already have my account cached, so I sign in. Now we're signed in. We can come back here and it'll say we're signed in. We can reset our password if we so choose on the account page. So then if we come back to the comments, we can see now we can post a comment. So let's say let's say I like ducks. Add the comment, and we can scroll down and see that our comment is right here. We can also refresh the page, reopen our extension, and see that our comment is still there. Lastly, if you want to sign out of the Chrome extension, you can come down here and click sign out, and you're officially signed out. You can see it shows we're signed out in the account tab, and then you can close it. So one of the big focuses we wanted in this project was infrastructure as code. So basically tracking what physical things we have and keeping them in code so that machines and computers can read it. So the first big tool we used for this was Terraform. Terraform pretty much just manages our AWS cloud resources. It does this by, it has a state file that it saves in AWS an S3 bucket, and each time you try to make a change in the Terraform, you run a Terraform command, and it'll manage the changes for you in configuration files. It also, each time you try to deploy, it'll display what will change, so you can be very specific in what will change, and you know what'll change when you deploy, so you don't deploy something that'll completely destroy your project. Lastly, this infrastructure is versioned in GitHub. Since our Terraform files live in our GitHub, they're automatically versioned with everything else that we write. The second tool that we used was GitHub workflows. So these are defined by workflow YAML files that are just define what steps should run inside of these workflow runners. They're basically just computers hosted by GitHub. And the workflow runners just run a set of commands called actions. Each action contains command line arguments, which is the really big, powerful part of them. Because of this, we can run AWS CLI and Terraform CLI, which are just command line interfaces, which let us do everything we do with Terraform and AWS, but with command line commands that computers can easily run. So as far as our pipeline deployment, we're using workflows in Terraform, obviously. Why we wanted to make a pipeline deployment? Well, basically, computers can run CLI commands really well. This removes any sort of human error with each deployment. Also enforces very uniform deployments, since the computer is going to run these commands the same way every single time. And if something ever does go wrong, it'll stop itself and it won't let you deploy. So we split our workflows, our pipeline, into two workflows, one verification and one deployment. The verification workflow must finish without an error to allow any sort of deployment workflow to run. And another big idea behind splitting these workflows was that our verification workflow triggers on every commit. There's not a big reason not to have it run on every commit because it's free for us to use this service. And also, our deployments have a manual trigger, since we don't want to deploy every single commit. We want that to be more controlled by humans, but it's a manual trigger, so the deployment still happens uniformly within a runner and won't have any sort of human error in it. So specifically, our verification workflow, it does a few things. The biggest thing, or one of the first things it does, is it pulls our source code and the dependencies of our source code. The purpose for this is just to have matching environments for running our unit tests. We automatically run our unit tests in our pipeline in the verification workflow, just to make sure that we aren't pushing any errors and aren't deploying any errors. This testing environment's very similar to our production environment, though the production environment is in an AWS Lambda, which is always going to be different than the GitHub runner. So one of the big purposes of the verification workflow is to check for bugs. It automatically runs our unit tests. And if the unit tests fail, it'll not allow continued actions, so we'll not allow a deployment if our unit tests fail. And lastly, the verification workflow runs a few Terraform commands. It verifies that the files that we have written currently are correct and that the changes won't differ too much from our production. It does that just to protect us from, again, destroying our project with changes that we didn't want. And lastly, the deployment workflow part of our pipeline. It configures our workflow runner with our AWS credentials, and it does this through going through GitHub secrets. You can save secrets in each GitHub repository, and it encrypts them so no one else can see them. But the workflow runners can easily access those secrets, so we save all of our credentials in those, and that's where our workflow runner picks them up from. We use these credentials in both the Lambda code, the AWS commands and the Terraform commands. Both of those need credentials to connect to our AWS so that they can see the state file that is out on AWS. Also, our deployment workflow at the end, it pulls the source code and dependencies. It needs these to make a package to deploy to the Lambda. And lastly, it just deploys the code to the Lambda and it applies our Terraform to our AWS architecture.
So that's it for our final presentation. If you have any questions, feel free to email any member of the group. And thank you for watching our final presentation video. Have a good day.